Well, I'm Ashish Jadhav, working in Department of Electronics and Telecommunication, Sweris College of Engineering, Pandharpur. I welcome you for this session on Industrial Internet of Things, which is popularly known as IIoT. So, IIoT has differences with the existing IoT, that is Internet of Things. Industrial Internet of Things has a different scope, and there are some specificities that are there in IIoT. So, we are going to understand this particular lecture for IIoT, what IIoT is, how it differs from regular IoT, and how IIoT solutions are helpful to real life industrial problems. It is in two parts. This particular lecture is in two parts. The first part, we are going to talk about some of the basics of IIoT. So we start with the quote by Paul Haworth, and what he has said that the IoT as a concept has crossed the chasm from slideware to reality with many industry implementing IoT solutions. So basically, you know what it means. It uh, is no longer IoT is no longer confined to theory and a type based on notion. It is no longer like that, so it is being used in reality in industry. Different IoT solutions are being implemented in the industry for solving different industry problems to make industrial processes, manufacturing processes much more efficient than the way it is at present. So let us try to understand IIoT versus IoT. As we have already understood through the previous lectures, that the main aim of IoT is to interconnect different things, and these things are different objects on the or the smart objects. So, what is required is to globally connect these smart objects or things so that the objects are uniquely identified and they are able to interconnect and exchange the information between themselves. We have different objects which are smart objects where there is intelligence that are embedded in the different things. So there are embedded systems that are attached to different things, worldly things, and these things, their abstraction as smart object, they are able to interconnect with each other, they are able to interwork with each other, and so on. So in contrast, in the industrial internet of things, we are focusing on industries, particularly focusing on industry systems, industry automation enterprise, system enterprise, and planning a product's life cycle, and so on. While we do it, we basically degrade from the core requirement of IoT, and there are some specific requirements which concern industrial processes that come into picture. So we are going to understand what these are in particular lecture. Before that, in terms of scope of IoT, basically it borrows some of the features of existing Internet of Things, plus it borrows some of the features from the vision of Industry 4.0. So, Industry 4.0 basically gives a framework for automation and data exchange in manufacturing technologies. So it is a vision, it is a way forward that has been proposed. So Industry 4.0 basically tries to improve the automation and data exchange in manufacturing technology. It tries to incorporate concepts from cyber physics systems, IoT cloud computing, and so on. So what we have essentially, it is uh, what we call a smart factory. So IIoT basically takes some of the features from regular IoT, that is conventional IoT, some of the features from Industry 4.0, and tries to have a separate vision, separate technology for itself. So what we have understood that whereas IIoT combines features from IoT and Industry 4.0, so it is not IoT as such. We have understood these things. There are certain features that have been borrowed from IoT, and but it is not IoT. IIoT and IoT are not the one and the same. They are not, where as IoT focuses on consumer level services, so consumer level products and so on. IIoT basically has the focus on enterprise. So the scope of IoT is consumer level, whereas the scope of IIoT is enterprise level. So the things such as concept technologies, methodologies such as machine learning, big data technology, M2M, that is machine to machine communication, automation, these are some of the integral components for building IIoT. So machine learning, I think we all understood machine learning is a very popular. It is a part of artificial intelligence. It is a kind of artificial intelligence. So which basically learns, so learning from the past, and there are different things, so there are different aspects of machine learning. Learning from data, the existing data, and trying to make things predictive and trying to have things which are better in future. So machine learning techniques and technologies are used in a big data. We are going to talk about big data later on. So in other lecture, we are going to talk about big data, how to handle big data, what are the tools that are available. So we will let us discuss about that when we talk about data handling and data analytics. The machine to machine interaction, machine to machine communication is about two machines directly talking to each other, directly communicating with each other, getting a particular work or task accomplished without any human interaction. So, for example, a robotic arm opening the door of a refrigerator and then performing certain other tasks in refrigerator. That is the example of machine to machine. So, maybe the robotic arm goes and opens the door of refrigerator, checks whether there is a sufficient milk in the milk pot of the refrigerator or not. If there is no or if there is a no sufficient milk, then the system as a whole will send, or the milk pot or refrigerator will send an SMS to the milk person. So what is happening in this entire process? There is no human interaction. So we have communicating the machine with another machine. we have machine to machine communication, M2M, without any human intervention. So, going back, we have machine to machine communication and automation. These are different features, different aspects of IIoT. So, IIoT is supported by huge amount of data collected from sensors. It is based on wrap and reuse approach rather than rip and replace approach. So, what is meant by these terms is when we talk about IIoT, we are not talking about building a new system from scratch. We are talking about using the existing manufacturing system, existing industrial system that you know, and wrap them with the sensors, actuators, and so on. Make these things efficient. So, we are trying to use the existing systems and processes, and we are not building anything brand new from scratch. So this is what we have to remember when we discuss IIoT. Let us try to understand the evolution of IIoT. So the first industrial evolution happened with the mechanized production. Then came mass production, which is the second industrial revolution. In the third industrial revolution, internet and automation was featured in manufacturing, and at present we have is the fourth industrial revolution, which incorporates IIoT. So IIoT is featured as a part of fourth industrial revolution. If we look at this particular figure, what we have starting from 70s, when there was power generation and mechanical automation. Then came the 80s, industrialization in 1990. We had this electronic automation, and at present we have smart automation. And this is how the industry 4.0 evolved today. So in industry 4.0, we have smart factories and so on in a industrial sector. When we talk about IIoT, it is about fourth generation of industrial automation. That means industry for 4.0 clubbed with the second generation of internet evolution. So internet at present, the first generation of internet is the internet that we all use, the regular internet with con- uh, connect connecting different computers throughout the world. This is the first generation of internet. In second generation of internet, it is about connecting different things, connecting different machines, and so on. So IIoT basically combines the second generation of internet, fourth generation of industrial automation, and cloud computing. So cloud has become a very popular technology since about more than half a decade or so on. Cloud has become a very popular since it is being used in industrial sector as well. So what happens is a cloud basically offers computational environment, computational infrastructure, computational platform, computational software in addition to regulate the storage. So cloud is like a huge data storage which can store a lot of data, and all these things, huge data storage coupled with infrastructure, software platform, hardware, and so on. Everything, one can get access to in an industry without basically having to purchase these uh, uh, purchase their own rights. So cloud computing is very popular, used not only in others sphere of everyday life but also in an industry. In the IoT network, we have physical objects that are interconnected. We have different systems, subsystems that are interconnected. There are different platforms types of platforms that work together, different applications, and so on. So these networks are IIoT networks can communicate with each other. External environment, they communicate with external environment and different people. So people are also a part of these IIoT network. There are different people, the different end users, stakeholder, everybody at enterprise level. Everything that is there, they are all form a part of IIoT. They have to be interconnected. Of course, they have to be connected. These things, the things, people, processes, everything together, they are connected. The acquisition of IoT has led to availability of and affordability of sensors, processors, and other technologies, which facilitate capture and access to real time information. So, all these IoT devices and wherever they are deployed through sensors. Sensors have become affordable, they are readily available nowadays. The different processes, other computers, other computing devices, technologies, and so on. They capture a lot of data and they offer the data in real time for further analysis, making these things much more efficient from the data that is collected. Moving ahead, IIoT for building. IIoT, there are four broad requirements. We need the hardware and software connectivity. We need a cloud platform, and I already told you briefly about necessity of cloud in industrial sector and how cloud can help with respect to processing infrastructure, data storage, and so on. Application development and big data analytics. Big data analytics is very important. All these different sensors in industrial sensors, the actuators that are fitted to these different machines, manufacturing equipments, and so on, they throw in lot of data, they throw in a lot of um, which is very important, and it is crucial. It can reveal a lot of information, and that by mining that data one can predict different things into a industrial processes, which is much more efficient. Different other views of IoT requirements. uh, One is access with respect to anytime, anywhere, anything connectivity. And anything connectivity is very important. It is a third dimension that has been added to anytime, everywhere, which was, you know uh, which was the vision of a communication, a system. So access can be the one that can have access anything, can be accessed at any time from anywhere in IIoT. End to end security is important, and that is not only important for IIoT but for any IoT based system. In fact, for any computer based system. Next is user experience. It is very crucial. Ultimately, it is all about offering services to the users, different stakeholders. So, user experience has to be taken up into account as one of the fundamental requirement for building IIoT. So what the user exactly want, how their problems can be addressed, how it can be solved, the problems can be solved, and uh, how the use of these systems that is being developed, the IoT system that is being developed, the user can do things better, and how their experience as a whole can be improved. Transition to smart machines. So machine, by adding sensors, actuators, etc., we are making the machine smart. Asset management is very important. Through asset management you can, you may know, through these different sensors, actuators, the assets can be managed, the industrial assets can be managed in a much more efficient way. So how the assets can be managed, this is one of the requirement that we have to consider for building IoT system. Next one is big data and the cloud. They are very important. Cloud offers storage, computational efficiency, and so on. Without basically having a one to a procedure, and by procure and deploy this computational infrastructure at their own workplaces or industrial, in the industry and big data, you already know that all these sensors, actuators, and each and everything that we have talked about so far, the enterprise level, at enterprise, people, process, things, and systems, they are going to throw in a lot of data. This data are going to be sent quite, uh, it is going to be sent in real time, and they have characteristics. They are not only big in volume, have uh, they have they come in a huge velocity. And you know, there are different types of data test: speech data, multimedia, other types of data like images, video, etc., all of which coming at the same time. It has to be handled, and so on. So this is what we are going to cover in the in one of the next lecture, when we are talking how to handle data handling and how to analyze the data which is received. So what want, what we have, what is required is to have virtualized version of a physical plant. So through IIoT systems, what we are trying to build is virtualized plant corresponding to a physical industrial plant. These physical plants and different machines in the plant are fitted with the different sensors, which throw which is in a lot of data, the sensors reading, and from this virtualized plant, lot of different types of instructions can be sent to physical plant, and then embedded system that are attached to these machines, to these instructions, can help to move over to perform different operations on these machines. So there are different considerations for building IIoT. To use an IoT device for industrial application, these design objectives have to be considered. Energy is a paramount of energy with respect to time, which the IoT device can operate with a limited power supply. So we have limited power supply, and we want to extend the lifetime of the IoT device that is installed, that is fitted with industry machine. Second is latency. It is crucial. It corresponds to the time that is required to transmit the data. Latency has to be minimized because let us say that we are talking about sensors that are fitted to welding machine. So if you see that if latency is not very minimum, then what is going to happen by the time the instruction reaches the machine, or the data is sent to the operator or from operator to machine. What happens is the welding machine might have performed more welding even in a fraction of seconds. So so more part will get welded which is not required. So the precision with respect to time is very important. And when we talk about the latency of operation, latency in a transition of data is very important, and it is to be minimized to extent possible. Next one is throughput. Is it is quite understandable. We need a maximum data to be transmitted across the IIoT network. Scalability is another aspect. Likewise, it is under stable. We are talking about not just one or two machines, but large number of machines in the IIoT sphere. So topologies, how these different uh, because ultimately what is going to happen is this sensor and this communication devices, they have they are going to interworked. So what we are going to have is network topology. And in this particular network topology, we have different devices with different specifications, and they have been manufactured individually by different vendors. So, in interpretability is very important. Not only that interpretability is important, but how these devices from the network is very crucial as well. So, the overall network topology formed out of the devices and how these devices interoperate with one another is something that has to be taken as one of the important primary design consideration in building IIoT. Uh, at last, safety and security. Likewise, I do not need to elaborate further, but they are very important issues that also have to be taken into consideration. Industrial safety, so we need to understand these things properly. When we are talking about automation as a whole in the industry, it should not happen, or things have to be reliable. The system have to be very reliable. It should not happen that the sensor is giving a wrong reading, because of which crankshaft or in some of fuel goes through causing accidents to the people who are worked in the plant, right? So industrial safety is very important. IIoT system automation, systems which offer automation, etc. They have to be very much reliable, and they have to be taken into account for safety and security of the application. Going back and trying to understand IIoT versus IoT. So whereas IoT traditionally focuses on convenience of individuals, IoT focuses on efficiency, safety, and security of the operation. In terms of machine to machine communication and machine to machine, I already spoke about earlier. In terms of machine to machine communication, IoT definitely uses this M2M, but it is not very exclusive. uh, the use of IoT machine to machine communication in IoT is limited, whereas IIoT extensively use machine to machine communication, M2M communication. It is extensively used in IIoT. The whole industrial operation in plant is automated. So one machine talking to another machine, second machine talking to third, to fourth, and so on. This is quite extensive. It is quite present in the industrial sector. So IIoT heavily depends on machine to machine communication, whereas IoT traditionally focuses on applications at consumer level. IIoT basically focuses on applications at industrial level, at the enterprise level. Let us look at one more aspect. So here M2M, where we talk about M2M. So M2M and IIoT. M2M focuses on device to device communication. There is a emphasis on communication between devices, between machines and IoT. On the other hand, focuses on the overall system integration of system components, subcomponents, subsystems, is uh, one of the important feature of IIoT. So this is what we need to understood. So M2M versus IoT. M2M focuses on devices, of course, both on M2M and IoT. They have focus on other aspects like network services, uh, network connectivity service enablement application, and data. These are therefore both M2M and IoT, whereas M2M focuses on particularly on devices, IoT basically focuses on the system level integration. Now, service management in IIoT is very important. It is all about why do you want IIoT? We want to offer improved services. So, service management is very crucial. So, service management basically what it is referring to is the implementation and management of the quality of services, which meets the need of end user demand, end user demands are met, and increasing the overall quality of services. So service is basically a collection of data and associated behavior to accomplish a particular function or feature of a device or portion of a device. So through IIoT solutions, the overall services, the management of the different services have to be improved. Now, let us talk about very briefly here the services can be of two types. One is primary service, and the other one is secondary service. Primary services are basically services which are responsible for primary node functions, whereas the secondary services are auxiliary functions which provides services to primary service, or secondary services are termed as secondary service. So what we have, primary service are a basically they are need those services, whereas secondary services are auxiliary services which may or may not be there. So with this we come to an end of first part of IIoT. We have understood basics of IIoT, how IIoT differ from IoT, what is the difference between IoT and M2M. So this is what we have looked at this part of the lecture on industrial internet of things. Thank you.